In this video lesson, we are going to cover the inorganic chemistry part of paper 2. As I told you earlier, the paper 2 of the paper 2 of A levels chemistry contains 3 sections. Section 1, inorganic physical chemistry. Section 2 is the inorganic, and section 3 is the organic. So now we are going to cover the B section of it that has to do with inorganic chemistry. Yeah, before I continue with the revision lesson, please, if you haven't subscribed, subscribe to our channel, but do not forget to hit the notification bell. But most importantly, I want to appreciate those who have subscribed to our channel. Thank you. Welcome back for taking your time and for taking your time to do that. So let's get started. We will be starting with question 3. This is June 2020. Question number 3. It reads, this question is on group 7 elements. Now the modern periodic table calls it group 17. From fluorine to iodine. Then S block, that is group 1 and 2. Then the period 1 and 2 elements of the periodic table. A1. State and explain the change in physical state of group 7. That is fluorine to iodine, as the group is descended. Okay, now in group 17, what was formerly called group 7, that is from fluorine to iodine, we have been asked to state and explain the change in physical state. You state and explain the change in physical. The physical state we have a liquid, solid, and liquid, solid, and gases. So we have to state whether they belong to this. So from fluorine to iodine, you will know that there is a change in the physical state. There is a change in the physical state. So in this question particularly, the physical state of the element down the group changes from gas, that is fluorine and chlorine, to liquid, that is bromine, and to solid, that is iodine. Again, I said the physical state will change. Physical state, that's one. For one, I said physical state down the group changes from, down the group it changes from gas, and the gas is fluorine, and chlorine, that is from gas, fluorine and chlorine, to what? To liquid. And in that liquid, we are talking of bromine. Liquid, we're talking of bromine. Then to what? Then and to solid. And this solid is what? Solid. And the solid is iodine. The solid is iodine. The solid is iodine. So the question says state. Our state is, they say state and explain. Explain means you have to give the reason for this change in the physical state. So we say the change is from gas to liquid, and then finally to solid. Our reason is, the reason is this one. Our reason, there is a change in the physical state from gas to liquid and to solid because of increased strength of the van der Waals forces. Our reason is increased due to increased strength of the van der Waals. Increased strength of van der Waals forces down the group. So now the physical state of the element down the group changes from gas, that is fluorine and chlorine, to liquid, that is bromine, and finally to solid, which is iodine, due to increased strength of the van der Waals forces. There is something I want to explain here. Van der Waals forces Van der Waals forces categorizes everything. It summarizes all the intermolecular forces. Van der Waals forces is the general name that is used for instantaneous induced dipole. Instantaneous induced dipole. It is the general name that is also used for intermolecular hydrogen bonding. It is the general name that is also used for permanent dipole attraction. So when it has a permanent dipole forces, intermolecular hydrogen bonding, and instantaneous dipole, induced dipole forces, all these we call them as van der Waals forces. And it should be noted that the van der Waals forces will increase. The strength of the van der Waals forces will increase with increasing number of electrons. And increasing as the molecular mass is increasing, the number of electrons are also increasing. And as the number of electrons are increasing, is the same way the van der Waals forces are increasing. And for that reason, when there is an increased strength of the van der Waals forces, high energy is needed to break the molecule. So that is why we leave from gases to liquid and finally to solid. Because as you go down the group, there is increase in the number of electrons. There is increase in the molecular mass. Subsequently, there is increased strength of the van der Waals forces down the group. Okay, thank you for that. 2. The second part of the question says, arrange the group 7 elements. The modern periodic table call it group 17. So arrange a group 7 element in order of increasing oxidizing strength. Oxidizing strength. What is oxidation? It should be noted that oxidation has to do with loss of electron. Oxidation is loss of electron. Oxidation is loss of electron. Now, oxidizing agent, the oxidizing strength, that is ability, is the opposite. Since oxidation is loss of electron, then oxidizing ability is that ability for that element to attract electron to itself, to take electron to itself. So oxidizing ability is the opposite of oxidation. So Oxidizing agent have that ability to take electron to themselves. So as you move down the group from fluorine, fluorine, chlorine, bromine, and iodine, the ability to attract electron to itself does what? It decreases. With fluorine having the highest ability to attract electron, followed by chlorine, then to bromine, and then finally to iodine. So the oxidizing ability, that ability to attract electron to themselves, will decrease down the group. We can now say that the oxidizing ability is in this form. We will say, because they have said, arrange the element in order of increasing oxidizing strength. Increasing oxidizing strength. That is from the lowest to the highest. And the lowest is iodine, followed by bromine, followed by chlorine, and finally fluorine. So this is an increasing order of the oxidizing strength. Then the question says again, explain the trend. Explain the trend. Why is it that the oxidizing strength is increasing as you go up the group? Why is it that the oxidizing is increasing as you go up the group? In that case, the explanation is that the oxidizing ability decreases down the group. The oxidizing ability decreases down the group because of increasing atomic size. Oxidizing ability decreases down the group because of increasing atomic size, with elements of the group having a high ability to take electrons from those below. Again, the oxidizing ability decreases down the group. Yeah, decreases down the group. It decreases down the group with elements of the group having a high ability to take electrons from those below. For instance, you will see that chlorine, aqueous plus a chlorine react with the sodium bromide in aqueous solution. You will see that this is a displacement reaction because it will be 2 sodium chloride, which is aqueous, plus this one. And balancing the equation, you will see that this will be there. So chlorine has a high oxidizing ability because it's going to displace bromine. Another example is when chlorine, if chlorine reacts with bromine plus bromide, this is the ionic form of it, which I'm trying to write here. This is the ionic part of it that I'm trying to write here. This is the ionic part of it. So I said the oxidizing ability will decrease down the group. So as you move from fluorine to chlorine, bromine, and iodine, the ability to attract electron to itself is decreasing. It decreases down the group because of the increasing atomic size. Because as you go down the group, the atomic size is increasing, with elements of the group having a high ability to take electrons from those below. In that case, it will look, this is a displacement reaction. Chlorine is up the group, is going to displace bromine here. So now it takes us to question number 3. Question number 3 that says write balanced chemical equation to show the reaction of chlorine gas with coal dilute potassium hydroxide. Coal dilute potassium hydroxide. Number 3. With coal dilute potassium hydroxide, you will see this. With coal dilute potassium hydroxide, you will see that that is number 3. Coal dilute potassium hydroxide, chlorine with cold dilute potassium hydroxide. In this reaction, what we are going to observe is it is going to form in aqueous condition aqueous condition is going to give us a salt. Potassium chloride will be formed. That will be the salt that will be formed, plus K O3 aqueous, and a molecule of water, and 3 moles of water. 3 moles of water that will be formed. Dilute. Dilute. Sorry, please. Sorry. I say with cold dilute. Sorry, please. With cold dilute, we will have, once more, we will have a chlorine aqueous plus potassium hydroxide, which is aqueous. I said there will be a salt there. There will be a salt plus aqueous plus water. So this is what is being produced under cold dilute with cold dilute potassium hydroxide at 15 degrees Celsius. Chlorine will react with 2 moles of potassium hydroxide to produce salt, and hypochlorous, that is K, ClO, aqueous is formed, and a molecule of water. But with hot, this is the A part of it. This is the A part of it with coal. Then there with the B part of it. The B part of it has to do with hot concentrated. With hot concentrated. Okay. Hot concentrated. Chlorine with hot. Chlorine with hot concentrated potassium hydroxide. Okay. With hot concentrated potassium hydroxide, we will have, there is a change. There is a change in the reaction. We will have um, plus 6 to give, will be 5. This is equals 5, yeah, plus this will be 3 plus 3 molecules of water. So you see that is the you see the change. The change here we call dilute. See the change here we call dilute. And see the change here. So you now see that there is a change there. Yeah. So that is what is being produced under hot with hot concentrated potassium hydroxide. That is what is being produced. Now, number four, give the oxidation, give the formula and the names of the name of the oxo acids of iodine in the following oxidation states. Okay, the following oxidation state we have also for +1, we will have this as it is a hypoiodose. If it is chlorine, we'll call it hypochloros. If it is bromine, we'll call it hypobromos. So it is hypoiodose for +1. In that case, we will have H. The formula is HO. If it was chlorine, it will be HOCl. But since it is iodine, it's HOI. And the name will be hypoiodose. Hypoiodose. Hypoiodose acid. If it was chlorine, we'll call it hypochlorous acid. If it is bromine, we'll call it hypobromous acid. Iodine, we'll call it hypoiodose acid. Then, with +5, the formula will be H, will be H I HiO3, HiO3. So, and the name will be iodic acid. It will be iodic acid. We can write it as iodic acid. Iodic acid. If it is chlorine, we'll call it the chloric acid. If it is bromine, we'll call it the bromic acid. Since the iodine, we'll call it iodic acid. So now it takes us to the B1 part. B1 part says, how does the second ionization energy vary for group 1 and group 2 elements in the same period of the element of the periodic table? The variation in the second ionization energy for group 1 and group 2. How does it vary? Generally, the second ionization energy, we can say the second ionization energy of group 1 and group 2. If we look at it, for the second ionization energy, generally the second ionization energy decreases down the group. We can say generally it decreases down the group. it decreases. It decreases down down the group. We can say the second ionization energy. The second ionization energy of group 1 and group 2 decreases down the group. Then give reason for your trend. Why does the second ionization energy of group 1 and group 2 decrease down the group? The simple explanation for this will be, the first reason for this will be 1. I can say as it decreases down the group, as you go down the group of the periodic table, what happens? There is the number of shells are increasing. As the number of shells are increasing, the valence electron or the outermost electrons go further away from the attraction of the nucleus. As they go further away from the nucleus, the attractive force between the nucleus and the valence electron is doing what? Is decreasing. And less energy is required to remove the second electron. So we now say down the group there is increased shielding down the group. Increased shielding. There's increased shielding. Increased shielding down. There is increased shielding down the group. That is, electrons are protected from the attraction of the nucleus as you go down the group because of increasing number of shells. Increased shielding down the group. Then we can say 2. Decrease in attraction, decrease in the attractive force between the nucleus. Force of attraction between the nucleus and the valence electron decreases. Decrease in attractive, decrease in attraction. Decrease in attraction between valence electrons and the nucleus. Decrease in attraction between valence electrons and the nucleus. Then finally, less energy is needed to remove the second electron. Less energy is needed to remove the second electron. So we now say the second ionization energy decreases down the group. The second ionization energy for group 1 and group 2 decreases down the group. That's the general trend. Then our reason for the trend, our reason for the trend is that as you go down the group, there's increased shielding. There's increased shielding down the group. Secondly, there is decrease in the attraction between the valence electron and the nucleus. And for that purpose, less energy is needed to remove the second electron. That's all. Then it takes us to the second one that says lithium. In the second section, we are told lithium shows a diagonal relationship. Lithium shows a diagonal relationship with magnesium. Lithium shows a diagonal relationship with magnesium. Lithium shows a diagonal relationship with magnesium. Why are these elements diagonally related? Why are these elements diagonally related? You should know that all of them, lithium and magnesium, if you look at them critically, they are diagonally related. So for that reason, the other one is in period 2 and the other one is in period 3. They are diagonally related. Why are these elements diagonally related? Okay, I can say lithium diagonal relationship is because both of them they have the same or they have identical ionic sizes. If you look the ionic size of lithium and the ionic size of magnesium, they are almost the same. So we can say both have identical ionic size. Why are these elements diagonally related? The other one belongs to period 1, period 2, and magnesium belongs to period 3. And for that reason, there's a diagonal relationship. Then, for purpose of revision, both of them have similar electronegativities. Both of them they are quite hard and they are lighter in nature. And their hydroxides, the hydroxide of lithium and magnesium are really they are weak bases. Their hydroxide are weak bases. So that is it. Question number 3. B. Give one reaction in which lithium and magnesium show a diagonal relationship. I think I have mentioned some reaction there. Lithium and magnesium, their diagonal relationship. Let me give the reaction with when they are heated with nitrogen. B. When heated with nitrogen, lithium plus nitrogen will give nitrite. They will give they will give nitrite. Yeah. They will give nitrite. So I can say both form they form ionic nitrate when heated in atmosphere. So they form ionic nitride. Form ionic nitride. They form ionic nitride when heated with hydrogen. They form ionic nitride with nitrogen. So both form ionic nitride when heated in the atmosphere with nitrogen. This is lithium. Lithium will react with nitrogen to form the nitride. The same thing with magnesium. Magnesium will react with nitrogen. It will react with nitrogen to give yeah 3 yeah 2. So I will have, let me say 3 here. Yeah. So magnesium 3 nitrogen 3. Very good. So now both of them will form nitride when they react with nitrogen in the atmosphere. When heated with nitrogen in the atmosphere, the result is nitrite. The result is a nitride that is formed. So lithium will react with nitrogen in the atmosphere to form lithium nitride. Magnesium will react with nitrogen in the atmosphere to form magnesium nitride. To form magnesium nitride. Yes, 3 nitrogen. Yeah. Okay. Yeah, nitride. They can form that. That's the reaction. Another reaction for this is both. Another reaction is that both nitrates will decompose on heating to give nitrogen dioxide. If you don't give this one, you can give this one. They are nitrate decomposed to give nitrogen dioxide. For example, this one will decompose, the nitrate of this will decompose on heating, to give lithium, yes, plus lithium here is 4. Yep, yeah, 4 here. Now again, magnesium on the other hand, magnesium nitrate, of magnesium, on heating we give magnesium oxide plus nitrogen dioxide, and plus oxygen. Magnesium here is 6. I want to balance it. 4 oxygen here, magnesium. Oxygen 6. 2 plus 2, 4, 5. I put a 2 here. If I put a 2 there, oxygen will be 6, 12. Put a 2 here, then it will be 2 times this. Let me put a 2 here. 2, 8. This is 8. 8 plus 2 is 10. Plus 2. That's good. Okay. Magnesium is 2. Nitrogen 4. Nitrogen here is 2. Nitrogen here is 2. 2 times is 4. Okay. Nitrogen is okay. So now we say both nitrates, the nitrates of lithium and the nitrates of magnesium, they decompose on heating to give nitrogen dioxide. You can say another reaction like the first one, lithium and magnesium both react when heated with nitrogen in the atmosphere. They produce nitrite. The nitrate one, when they decompose, they give nitrogen dioxide. So that is a similar example to show. That's an example you can give. Okay. With the use of chemical equation, show the effect of heat on the nitrate of lithium and potassium. Okay. Again, this is for lithium and potassium. That is 3 for lithium and potassium. Lithium and potassium. Okay, like the lithium, the nitrate, that is 3. The third part of it is 3. Okay, lithium nitrate, like the one we just mentioned above. Lithium nitrate, that is 4. Lithium nitrate. We will have 2. Yeah. That is a solid that is formed. The one is also a solid. Plus 4 nitrogen dioxide, which is a gas, and oxygen, which is also a gas. Excuse me. Now the nitrate of potassium. The nitrate of potassium will have 2 potassium nitrate. It is also a solid that will decompose when heated to give 2 potassium O2, which is a solid, plus oxygen, which is a gas. So that is what you will have on the heat, effect of heat on this. That's what you have, effect of heat on the nitrate of lithium and the nitrate of potassium. So that will be the result of it. Okay, it takes us to this other question that says, how does the solubility of hydroxide of group 2 element vary down the group? As you go down the group, the solubility of the hydroxide, as you go down the group, the solubility of hydroxide varies. And how does it vary? Now, as you go down the group, the atomic size of the elements are increasing. So, if the atomic size is increasing, the force of attraction between them is doing what? The nucleus and the outer electrons is decreasing. Now, the larger the molecule, the less the attractive force between the molecules. So we can now summarizingly say that the solubility of hydroxide of group 2 element down the group will decrease. Solubility will decrease down the group. Solubility of group 2 elements. Solubility of group 2 element. Solubility of group 2 hydroxide. Solubility of hydroxide of group 2. Solubility of group 2 hydroxide. Solubility of group 2 hydroxides decreases down even though all of them they have the same charge, but the atomic size is the one influencing this. So as you go down, the larger the atomic size. So we can say that has a role to play in the ability to dissolve, the ability of the hydroxides to dissolve. So we can now say the solubility of hydroxide of group 2 elements decreases down the group. Solubility of group 2 hydroxide decreases down the group. It takes us to the other side. Okay, the C part of it says, in the space provided, sketch a graph of variation of the first ionization energy for the element sodium to argon. This is the first ionization energy. If you look from sodium to argon of period 3 of the periodic table, you will see that there is the general trend is that there is a consistent increase as you move across the period. The reason is that as you move across the period, there is an increase in the nuclear charge. There is an increase in the nuclear charge resulting from increasing what? From increasing number of proton. But there are some variations there, especially in group 13, especially in group 13 here, and also in group 16 here. There is a drop. There is an increase, there is a drop at aluminum, and there is a drop at sulfur. That reason we gave in our previous video. So if you were to sketch the first ionization energy of the elements across the third period from sodium to argon. This is how the sketch is supposed to be. It starts from right down from sodium right up to magnesium and then drops. Then again increases to phosphorus and then drop at sulfur. And now it increases. So that is how the whole thing is. Like in a zigzag form. So you can do it like that, but consistently increasing except at group 13 and group 16. Sketch that. In the space provided, you have that. Now, in complete the table below, giving the formulae of the oxides of the elements. These are the elements, formula of stable oxides. The formula of stable oxide for this, we will have formula of stable oxide for this, we will have for lithium, we will have something like lithium oxide will be something like Li2O. Yeah. For beryllium, we will have something like this, BOO. For boron, we will have something like B with oxygen valency with 2, oxygen 3, something like that. For carbon, we will have 2 stable oxides. We will have oxides like a carbon monoxide and carbon dioxide. And for nitrogen, we will also have nitrogen monoxide and nitrogen dioxide. And then for fluorine, we will have F valence of 2, then with oxygen. Yeah, we will have something like that. Then they said from the list of oxide in C2, select an oxide which is likely to be amphoteric. An oxide that is amphoteric that have both only group 13 and group 13, that is boron and aluminum, they have that. So group 13 will definitely have this as amphoteric. Amphoteric would definitely be something like B2O3. That will be the one. Then a neutral oxide will be something, because carbon dioxide is acidic. Carbon dioxide is acidic. So a neutral oxide would definitely be carbon monoxide. Would definitely be carbon monoxide. Then acidic oxide. There are 2 acidic oxides. There is nitrogen dioxide and there is carbon dioxide. About greenhouse gases. You've studied about greenhouse gases. Carbon dioxide is an example of a greenhouse gas. Nitrogen dioxide is an example of a greenhouse gas, and sulfur dioxide is an example of a greenhouse gas. But sulfur is not here. All the greenhouse gases are the one that go into the atmosphere and cause acidic rain. When they react, the greenhouse gases that are acidic, there is nitrogen dioxide, there is carbon dioxide, and there is sulfur dioxide. All these, when they go into the atmosphere, they react with oxygen. They react with water and come down as acidic rain. Now, carbon dioxide will come with a carbonic acid. Nitrogen dioxide will now result in nitric acid or nitrous acid, and the sulfur dioxide will now come with sulfuric acid. So now, sulfur is not there. We have but nitrogen dioxide and carbon dioxide. So acidic gas, any of these of the acidic gases will be a carbon dioxide or a nitrogen dioxide. A nitrogen dioxide. That is what you can get. So if you have this, then you have got everything. So in that case, a recap. We said the first part of the inorganic chemistry is this one. We have given our train. For the physical state of group 7 elements. We said they move from from gas to liquid and to solid. And the reason is that because of increasing strength of the van der Waals forces as you move down the group. Finish. Remember, van der Waals forces increase with increasing number of electrons. Remember, van der Waals forces increase with increasing molecular mass. So now we're told in two to arrange the group 7 element in order of increasing oxidizing strength. Oxidizing strength is ability to accept electron, to draw electron towards yourself. So in that case, fluorine has the highest oxidizing agent in group 7 because it has the highest ability to attract electron. So increasing order will be from iodine, bromine, chlorine, and finally the highest one, the most oxidizing one is fluorine. Now they said, explain the trend. I said the oxidizing ability decreases down the group because of increasing atomic size, with elements of the group having a higher ability to take electrons from those below. I gave an example that a chlorine can displace bromine because it is a stronger oxidizing agent. So this is the chemical equation and this is the ionic equation. Then I went further again to write 3. Write balanced chemical equation to show the reaction of chlorine with coal dilute. With coal dilute, I said chlorine will react with potassium hydroxide. It will give potassium chloride as a salt, then KClO plus water. Then with hot concentrated, I said it will give 5 potassium chloride plus KClO3 plus 3 moles of water. Now, I went further again. They said the last one was give the formula for the oxo acid of iodine in the following oxidation state. I said it is HOI and the name is hypoiodous acid. For plus 5, I said it is HiO3 and the name is iodic acid. Now, how does the second Einstein energy vary down the group? I said it decreases down the group. The reason is that increased shielding down the group leads to decrease in attraction between the valence electron and the nucleus. For that purpose, less energy is needed to remove the second electron. Now, the diagonal relationship between this one, the diagonal relationship, I said the diagonal relationship is, first of all, the other one belongs to period 3, period 2, and the other one is period 3. That diagonal relationship, why are these elements diagonally related? They are diagonally related because they belong to different periods of the periodic table. They belong to different periods of the periodic table. For that purpose, they have almost similar ionic sizes. They have almost similar ionic sizes. So that is one of the reasons. So they have almost similar ionic size, almost identical ionic size, and that can be shown in their chemical activity. So it went further to say, give one reaction which lithium and magnesium show a diagonal relationship. Okay, because you know that they have a diagonal relationship physically and chemically. Physically in their identical ionic size, and chemically they react. An example of it is that they react to form ionic nitrate when burnt in nitrogen in the atmosphere. Lithium will react with nitrogen to form what? To form ionic nitrate. Then, went further again, give the reaction with the use of chemical equations, show the effect of heat on nitrates of lithium and potassium. lithium, the nitrates, when they decompose, when heated, they will decompose to give oxides. To give lithium will give lithium oxide and nitrogen dioxide plus oxygen. Potassium nitrate will give potassium dioxide. Will give will give KNO2 plus oxygen. So at the end of the day, all of them will give oxygen. Then a reaction with how does the solubility of group 2 vary down the group? I said the solubility of group 2 hydroxide will decrease down the group. It will decrease down the group. Then in the space, sketching the first energy of elements of period 3 sodium to argon. This is the sketch of it. Then again, oxides of group period oxides of period 2 lithium to fluorine. We have, then from there I get the oxides. Then there are some that are amphoteric, that is a B2O3. There's one that is neutral, carbon monoxide, and the one that is, there are two that are acidic, carbon dioxide and the nitrogen dioxide. Then, and that is all. Our next question will be targeting, we will be targeting some questions on the D block elements. We will be targeting questions on the D block element, sulfur, nitrogen, and group 4 in our next question. So thank you very much for listening. I still want to thank you, especially those who have subscribed. Thank you for encouraging us by subscribing to our channel. For those who haven't subscribed, please, we need your support. Do not go without subscribing to our channel, without liking our video, without making comments, and without sharing to other fellow learners. Thank you. Wishing you best of luck.